Welcome to another session of the PMDG MD11 training from Angle of Attack. So we are finally to the flights, and this is the first flight. And as always, with any good flight comes the planning stage, so that'll be what we do first. This first flight, in response to your votes, will be a short haul from Heathrow Airport in the UK to Palma de Mallorca in Spain. Much work goes into the planning of any flight, and we will give this one all the attention it deserves. Firstly, we will need to decide on our route, so we do of course know our origin and destination. However, we need to determine how best to travel between them. Now, in the real world, pilots are almost always given their route by dispatch. However, we have no such luxury here as flight simmers, so we will need to make use of one of several tools available to us that will generate an appropriate route. We won't go into too much detail on the different planners, but we thought it important to list a few of the free alternatives to those that we'll be using, which are paid options. Route Finder's free service allows entry of departure, destination, en route altitude, and an option to select the AIRAC cycle, useful for matching up with your installed nav data. The route that it computes is presented simply, but it gives ample information for programming your FMC or MCDO. Another alternative is FLIGHT1, which provides free flight tracking for commercial aircraft. It shows route information for real flights, which is easily entered into your FMC so long as you have the up-to-date nav data. Now, while some parts of Europe are covered, it does not provide route information there, so we will not be able to use it for this flight, as we will be flying in Europe, obviously. Last in the free options, I'll mention VAT-Aware, which provides flight tracking history for VATSIM. A particularly useful feature is city pair search, which allows origin and destination airports to be entered. This, among other things, lists the top 10 routes used between the selected airports. Now, if you're not into working these things out yourself, this is a great place to come. It's a fair bet that if this route was used for 30% of the flights over the last 12 months on VATSIM, it'll work out just fine for you as well. So there are a few payware alternatives to FS Build, which is the payware program that we will be using for our flight planning. One that stands out to us as a good, well-priced comprehensive package is VRoute Premium. It is a little simpler than FS Build, which could be an advantage. However, it does pack in weather integration and also allows the user to export flight plans to formats that can be read by the aircraft's FMC, which FS Build does too, but not as easily. Moving on from the alternatives, let's dive into planning our flight from Heathrow to Palma. For this particular flight, we will use two programs to gather the information we need: FS Build and TopCat. FS Build will give us our flight plan information, and TopCat will provide all the weight and balance, takeoff and landing data that we need. Given that we're teaching the MD11 here, we'll explain only the features of each program that we will actually be using. So don't worry, we'll go into enough depth that you'll be able to replicate this for other flights in the future. Open up FS Build now and let's get started. We will be flying from Echo Golf Lima Lima Heathrow using runway 09er right, and then via the Midhurst 3 Juliet departure to Lima Echo Papa Alpha, which is Palma, runway 24 left, and the Lores 1 Papa arrival. We are doing things a little differently on this first flight, as we have already manually formulated a route that is simple and is short enough that it will allow us to demonstrate the flight plan install into the MCDO without wasting a lot of time. When we come to the next two flights, we will press the auto-generate button, which will generate a route for us. I have pasted our route into the flight plan box. Our flight will take us from Heathrow, runway 09er right, via the Midhurst 3 Juliet SID to the Midhurst VOR, then via Airway Uniform Lima 151 to Sitet, Airway Uniform November 859er to the Barcelona VOR, then via Airway Uniform Whiskey 7 to Lores, and finally via the Lores 1 Papa Star to runway 24 left at Lima Echo Papa Alpha, which is Palma. Our alternate will be Lima Echo India Bravo, Ibiza, and our cruise altitude, which we need to enter here, will be flight level 330. Go to the aircraft folder on the left in FS Build and select the CF6 equipped PMDG MD11 toward the bottom of the list or wherever you had placed it. We'll now need to step out of FS Build for a moment and configure our aircraft payload. FS Build will calculate the fuel we require for our flight. However, we will need to give it payload information to give it accurate data. We will configure the aircraft loading Topcat for those weights. To start with, we will need to create an aircraft profile for the MD11. So click the Add button in Topcat and the Add New Aircraft screen will pop up. So let's run through this now. Our particular aircraft's registration is November Alpha 0 Alpha 02. Type is, of course, the MD11F, and we use the CF6 engines. We will be using an assumed temperature takeoff, so make sure that this here is selected. The next step is very important. We need to tell Topcat where our MD11's aircraft CFG file is located so that we can export our payload to the aircraft. This allows us to pretty much bypass the PMDG load manager and save some time. So click Browse and navigate to your aircraft CFG file. So basically what you want to do is you want to go to your C drive. That's where I install everything. And from there you want to click on Program Files, Microsoft Games, Microsoft Flight Simulator. And then we will go to Sim Objects. Now if you are in FS 2004, you're going to click on Aircraft. But in this particular case, in FSX, I'm going to click on Sim Objects, Airplanes, scroll to the bottom, and we're looking for the PMDG underscore MD11F. I'm going to click on that folder, select the aircraft CFG, and from there we can then select the angle of attack logistics livery so we can select the different liveries, and this is very important. We will be using the angle of attack livery throughout our flights, so make sure that this is selected. Now throughout all 3 flights we will use pounds for weights, feet for lengths, and gallons for fuel quantity. In fact, we normally refer to fuel quantity as a weight, but gallons is the right setting here. So for this flight, since it is within Europe, we will use hectopascals for the pressure, as that is the kind of altimeter setting that they use. Aircraft configuration is the PMDG freighter, and you can select FS 2004 or the regular. I'm assuming the regular is FSX, and I'm not sure it actually matters in this case. Passenger capacity is understandably nil because we have a cargo aircraft. Default cargo and fuel capacities are correct. We don't need to worry about a SELCAL code in our case. This may be something that we cover later. I will amend these weights slightly down at the bottom, so dry operating weight is fine. However, maximum zero fuel weight will need to change to 461,300, so 461,300 pounds. Maximum takeoff weight is fine, and maximum landing weight should be 491,500. So really we're only changing one digit in either of those. All is set up for this page, so we'll press save to save the changes. So select your new aircraft profile, or it might already be selected, and then press the weight and balance button to get to the weight and balance tab. This area allows us to specify aircraft loading and its distribution. Registration, type, and weight units are correct. Passenger load is not applicable as we are a cargo aircraft again. In the bottom left here, we set our cargo payload. Type of flight is international from the drop down. And business is good, so let's give it a good 80% capacity. You can drag this slider to whatever value you want, but for simplicity's sake, I've already saved a set of numbers here. So let's put in 153,090 pounds for the cargo and 22,8 0.75 pounds for the male. On a short haul flight, we will be nowhere near our maximum takeoff weight with this MD11, but remember this total payload figure here. We will need to bring this over to FS Build in a moment. Now that we've finalized our payload over here, let's make a note of it and head back over to FS Build. So still on the aircraft page, looking over at the right hand side of the page, our call sign will be AOA001. Empty weight, you can grab from TopCat if you don't remember, is 250996 for the freighter variant. And payload weight is 175965. Average route winds will be 0. We have decided against using winds a lot for this flight for various reasons, and mainly for simplicity actually. We will specify 900 pounds of taxi fuel, which equates to about 10 minutes of taxi time after engine start. We will leave the rest of the fields as they are, and this will give us ample reserves and keeps us within regulations. So 30 minutes reserve fuel, 30 minutes for any holding procedures, and an extra 30 on top of that just to be safe. We will leave the alternate box blank as FS Build will calculate the fuel required for us. With this information filled out, we can return to the route on the left and press the Build button to complete the route. So we are now presented with a list of all the waypoints en route and a wealth of other information. Note the route displayed on the map also. Now the Navlog tab is where our Navlog gets displayed. We can print this or export it to PDF. It is the file that we provide as part of the dispatch release where the files are located. We'll actually leave FS Build now and use solely the Navlog we have just created for reference. It contains all the information that we will need from here on out. So let's go back to TopCat now and finish up the aircraft loading. Now so far all we have finalized is the cargo loading, but we have yet to add fuel. TopCat does have a very rudimentary but pretty accurate fuel planner. Nick has amended an FS Build profile to give fairly accurate estimates for this flight, and we will be using that for our fuel loading. Due, however, to the fact that Boeing did not make fuel burn data freely available to PMDG for publishing, we can only work to a certain degree of accuracy, so don't expect absolute perfect numbers, and I would guess that in the real world it would be the same case. There are just way too many variables. So flight number is AOA001, and we'll be going from Heathrow to Palma. Distance per the FS Build Navlog is 800 nautical miles. As I said, we will be using the FS Build fuel figures, but let's hit estimate and see what it comes up with. We can compare this with what FS Build gives us. Required fuel in FS Build is 59943, and TopCat gives us 59800. So not too bad. It'll be interesting to see what the FMS predicts once we get up in the air. So enter the FS Build value, rounded up to the next 100, into the fuel on board. This will be around 60,000 pounds of fuel. So enter trip fuel of 31,019 pounds. The reason that we round off the total fuel like this on the fuel on board is that we can only load round numbers through the PMDG Fuel Manager. So with the fuel entered, we have fully loaded the aircraft. We can hit the payload distribution button and make sure with reference to the graph that the 0 fuel weight, landing weight, and takeoff weight are within the MAC limits. They are, so we are all set there. Now let's quickly run through the weight and balance summary here. Dry operating weight is the weight of the aircraft operationally ready without fuel or payload. If you add payload to this, you get 0 fuel weight. If you add takeoff fuel to this, you get takeoff weight. If you subtract trip fuel from this, you get the landing weight. Centers of gravity for each weight are shown here, expressed as a percentage of the mean aerodynamic chord. Now, Top Cat does not provide stabilizer trim settings for the MD11. We will need to reference the FMC for that information later, as you will see. Max weights on the right are set correctly. If we exceeded the limits, we would get a warning from Top Cat. Ibiza is selected as our alternate again. Pressing the load sheet button allows us to export the load sheet to text format. This is the load sheet file that we provide. By pressing export to Flight Sim, we can export this load data to the aircraft config file. So press save to do this. This allows us to bypass the PMDG load manager, which takes the program out of the equation and simplifies things a little bit for our setup. And we will still need to load fuel manually once we get into the aircraft, so be ready for that. So we're done now with the weight and balance page, the great weight and balance page, and the aircraft has been loaded, and we have the load sheet, which we will reference during the MCDO setup. So moving on to the takeoff screen in Top Cat, we have a lot of information to enter. We have some weather to enter, so let's have a look at the current METAR. Looks like Heathrow weather on the 12th day of the month, 1200 Zulu, is wind 070 at 16 knots. We have light rain showers, overcast at 3,400 feet, temperature 5, dew point 3, QNH 990, and no other significant weather to report. So we need to enter weather conditions pertinent for our takeoff, and that means that wind is 060 at 16, and notice that when we punch this in, it calculates the headwind and crosswind components for us. Temperature is plus 5 degrees Celsius, as we talked about. The QNH is 990 hectopascals. There's also rain reported in the METAR, so the runway condition will need to be wet from the drop down. We now have an option of downloading current real-world weather, and we obviously don't want to do this, so we will leave this alone for now. Under configuration, verify that takeoff weight matches the load sheet of 486061. We now need to select our flaps settings. So flap settings permitted are the entire dial of flap range from 10 to 25. The dial of flap system in the MD11 was devised so that the flap settings could be set very specifically for different takeoff conditions. Many airlines, however, just use a fixed value for all normal operations. So for simplicity's sake, we will use flaps 20 across the board for all the flights that we do. Thrust config is normal. We will take off with packs on. We will be using engine and airfoil anti-ice as temperature is below 6 degrees Celsius. Because these systems run on bleed air, this will result in more load on the engines and thus a longer takeoff roll. So that's why it matters that we say that we're using anti-ice. Airport should already be set for Heathrow, and our departure runway will be runway 09 right. It is worth checking over the information here to make sure that it is all correct, and all is fine in our case. There is no temporary runway shortening in place, and we have no inoperative items to consider here. So with all figured information entered, press compute to process it all. After a few seconds, once that is finished, full thrust will be shown at the top here and assumed flex thrust settings shown below. It is possible to reduce thrust takeoff by tricking the aircraft into thinking that the outside air temperature is higher than it actually is. This saves on fuel consumption and engine wear, and that is a much more in-depth and difficult subject, but that about sums it up. So in our case, however, we have a takeoff on our wet runway and anti-ice on. I will therefore elect as pilot in command to conduct a full thrust takeoff, which will really allow us to rocket out of here. I have little doubt that we would be able to get away with a thrust reduction. However, it is not by any means necessary. We will cover assumed temperatures in more detail on the following flights, but for this one, we will keep it simple and select the top value. This will give us a very healthy 5,920 feet stopping margin, nearly halfway of the runway. So double click on the full thrust selection to bring up the takeoff results export tool. This file is also included in the files we provide here. In addition to this, we want a takeoff report as well, so this can be found by clicking on the TLR button, then selecting Takeoff Report. Verify that all of the location, runway, weather configuration, and weight settings are correct. So untick the reduced thrust, as this does not apply for us for this takeoff today. Select None for additional runways, and then press Generate to export the file. Again, and I'm sure you've noticed a pattern developing by now, we include this file in the dispatch documents. To finish up the planning, let's run through the documentation we have so far. There is a lot of it, so listen up. We'll start with the load sheet. From Heathrow to Palma de Mallorca, flight AOA 001, registration is correct. Aircraft type is the MD11 freighter with CF6 engines. Payload is made up entirely of freight, except for me and you, I suppose. Distribution breakdown is shown here by compartment. Total payload is 175,965 pounds. Dry operating weight is 250,996 pounds. Zero fuel weight is 426,961 pounds. Takeoff fuel is 59,100 pounds. Takeoff weight will be 486,061 pounds. Trip fuel is estimated at 31,019 pounds. Landing weight is estimated at 455,042 pounds, well within the limit. Taxi out fuel is 900 pounds. This added to our takeoff fuel gives us 60,000 pounds, which is the fuel that we will load once we get into the aircraft. Underload before last minute change is 34,339. Any last minute change to our loading must not exceed this value, as that would cause us to exceed the maximum zero fuel weight. Last minute change total shows 0, and we have not made any last minute changes. Center of gravity values are shown here, expressed as a percentage of the mean aerodynamic chord, as we talked about before. We will input the top two values in the McDo later on. The MAC limits are also shown here, both fore and aft. We are well within those limits. Block fuel and estimated landing fuel are shown here. That concludes the load sheet. So on to the flight plan navlog. All the information at the top is correct. Worth noting is that these figures are for a Mach 0.825 cruise, which is achieved by a cost index of 80, which we will use as standard. I will only draw your attention to the most important information here, as other information will just be repetitive. So taxi fuel is 900 pounds, which gives us 10 minutes taxi time. Trip fuel is 31,019 pounds, which we inputted into TopCat earlier. Reserve, alternate, holding, and extra fuel are all filled out. A 15-minute hop is estimated for our alternate. Required fuel is 59,943, which, as covered, we have rounded up to 60,000 pounds. Takeoff and landing weights are almost identical to the TopCat values. However, there are very slight differences due to our having rounded up to 60,000 in TopCat. So reference the TopCat values for the takeoff and landing weights and not these weights. Alternate is Ibiza, distance 75 from Palma de Mallorca. Zero fuel weight is correct and payload is correct. Total route distance is 800 nautical miles. The abbreviated route is shown here. This is what we will use for the initial McDo programming, which you will see here coming up soon. The rest of the navlog is fairly self-explanatory. Just to clarify, the ACBO column shows forecast fuel burn by each waypoint, and the remaining column shows the forecast fuel remaining at each waypoint. So next up, I will go through the takeoff results information. Takeoff from Heathrow, runway 09er right. Takeoff runway available is 12,008 feet. Registration and aircraft type are correct, which is always encouraging at this point. Temperature is 5 degrees Celsius, positive 5 degrees Celsius. QNH is 90 hectopascals. Wind is 070 at 16 knots, which gives a 14 knot headwind component. Aircraft configuration is flaps 20, normal takeoff, packs on, and engine and airfoil anti-ice is on, and runway is wet. We've been through all of that before, but we are just double checking now. This will be a full thrust takeoff, no thrust reduction. Max takeoff weight at this thrust is shown as 638,528 pounds. It is worth noting that actual max certificated takeoff weight for our aircraft is 630,500 pounds, so this is actually over it. V1 decision speed range is between 135 and 152 knots. VR is 152 knots, and V2 is 163 knots. We will take whatever V speeds the aircraft calculates once we input runway and weather information into the McDo later on. Stopping margin is 5,920 feet. This means that we should have 5,920 feet of runway remaining for a rejected takeoff at V1. We are well clear of the max takeoff weight limit that we talked about earlier of 630,500 pounds. So always check the engine out procedure on the chart and follow that if different to what Top Cat tells you. I will not go over the takeoff report file as most of this information is covered by the takeoff results file, but make sure you go over it before you take off. So that concludes the planning. Be sure to check over all the documentation yourself and be fully comfortable with it before you move on to the flight video. So we will see you soon on the flight deck.